All right, question number 1 from the practice exam. We want to draw a free body diagram in part A. So we're going to have normal, we're going to have weight, we're going to have the friction force, and we're going to have the spring force pulling the spring back towards the wall here. And of course friction opposes that, that's why we have the directions. Now what I'm going to do is I'm going to set up the equilibrium equations, meaning normal balances weight. And for part B, we're told that friction is balancing the spring force because the spring isn't moving yet. So I set these two things equal. Now what we need to do is we actually need to go ahead and calculate what the stretching distance is given the fact that all these forces balance. So I know that the normal equals the weight, and I'm going to actually write that calculation up here that's going to equal mg, and when we put in the numbers, that's going to be 9.8 newtons, because that's 1, and that's 9.8. Now, we then can set the friction force equal to mu times n, so that's going to be 0.4 times the normal force, which is 9.8. So I just want to remind you here that friction is mu times n. And so we actually go ahead and we're going to then set the spring force equal to this friction force, and that means 0.4 times 9.8 is going to equal the spring force, which is K times X, and K we're going to put in 20 because that's what K is right here. When we calculate X, we're going to end up getting 3.92 newtons. Finally, how much energy is stored in the spring? E elastic is 1/2 kx squared. That's going to be 1/2 times 20 times 3.92 squared, and that's going to work out to about 153.7 joules.